So microservices are great, but they come with a warning. It says handle with care. And one such thing that you need to definitely handle with care is timeouts. Right? So in this video, let's talk about what exactly is the problem with timeout, or what exactly is the problem with communication that requires us to have basically timeouts in place, and discuss 5 approaches that would help you handle timeouts better and build a very robust microservices based architecture. So microservices are great because you have a total separation of concern because your service is focused on only on that one thing. It gives you flexibility and team's agility because you can just hire specific set of people to solve that one problem really very well, which means scaling will not be a problem. As you're picking the best tech stack to solve that problem, no hacks involved. So everything's great, but one concern that comes in when two services are talking to each other. When two services talk to each other, we need to handle timeouts. Like let's consider a scenario. Let's say we are building a search service. Let's say we are search team, and what we use Elasticsearch to find the most relevant search results for a particular query using and then the entities on which you are building search is, let's say, blogs, right? And what happens there is user fires a search query. For that given search query, using Elasticsearch, we find the most relevant blogs. And we want to serve this result to the user. So we cannot directly send this response to the user because there is one attribute that needs to be filled. And this attribute is the total number of views that the blog got to date, right? So when the query was fired, what is the total number of views that the blog got? Now, in order to get this one attribute, what search service would have to do is would have to talk to analytics service, which has this information, right? Now here, this communication becomes a synchronous communication because user is firing a search query, request comes to search service first computes the most relevant document with Elasticsearch, then it immediately fires a query, a request to analytics service, which says that, hey, these are the blog IDs. Give me basic analytics information of all of these blogs. So it uses, let's say, MongoDB as its database. It gets that information, sends it to the search service that injects that information in the response and sends it to the user. So here the problem, because this is a synchronous dependency, the problem comes up when your analytics service is not responding fast enough, right? Or not responding at all, right? Then how long should your search service wait for a response from the analytics service? That's the concern. Like, should it wait forever? Of course not. It needs to wait for a maximum, for some time, which is the maximum that it can wait. Right? And then if it did not get response in that time, what action should search service take? Like, either it can send a partial response that it has to the user, or it can choose to not send any response to the user, right? So this is how you need to handle the timeout. So this is very domain specific decision that you will be taking, but you need to be aware that, hey, what if the timeout happens? What should be the behavior in that case, right? So let's understand what actually could go wrong, right, when there is this inter-service communication, right? So because once we know what could go wrong, we can then decide on the approaches that we would take. So first thing that could go wrong is when there is this inter-service communication is where, let's say, somehow the request made by the search service never reached the analytics service. So it thought that it made a request and it is waiting for the response and all, but the request didn't even reach there. This flow would not happen when you have a TCP based communication. Let's say you are making an HTTP call to analytics service to get that information. This is not possible in that case because if you are unable to create your TCP connection, then you would definitely know about it, right, as part of your exception or something. But due to network congestion, due to an asynchronous communication, this could happen where you think that you fired a request and waiting for a response, but this request never reached analytics service for some reason. Second is, although your request reached the analytics service performed a computation, but when it sent a response, the response never reached you due to network congestion, broken connection and whatnot. Right? This could be second possible case. Third possible case would be your search service made a request to analytics service. Analytics service is computing the response and is taking too long to compute the response. Maybe because it is having a database outage. Maybe because it is doing a lot of heavy processing. Maybe because it is overload, like the API server of it is overload and whatnot. And there could be n number of reasons to do that. Like there are so many things that can go wrong when you are having a synchronous dependency on a different microservice. So which is where we talk about like how do we solve this problem. That is where the first thing that we always need to take care, always, like no matter what, we always have to take care of, that whenever you are making a network call, add a timeout to it. Always use timeouts whenever you are making a synchronous call to a service. You do not, or you cannot, and you should not wait forever for the response to reach you. Like it should be like, hey, I'll wait at max for let's say 1 second, 2 seconds, 5 seconds, 10 seconds, depending on your domain. And then if you don't get a response, then you say, hey, now it's a timeout. Now I'll do whatever I want. I was waiting for response enough. So it's like it's like two friends decided to, like you and your friend decided to meet and your friend didn't show up. How long would you wait? You can't wait forever. You have to wait for a max duration, let's say 10 minutes, 15 minutes, and then you say, hey, chalo, I'm going. Right? So this is that exact same thing where two friends trying to meet, one friend didn't show up. How long should the first friend wait? So the maximum time that it would wait is called as a timeout. Right? So and the timeout is not something which is very, it is very prescriptive. It depends on the use case that you have, that how long should be the timeout. Let's say in a service like search, although I wrote 10 seconds, but in a service like search, you don't want your end user to wait for even more than a second. Your search result needs to be served very fast. So it might be in like 200 milliseconds, 300 milliseconds, 500 milliseconds, but there has to be this timeout that other service agrees on. Okay, hey, I'll be, no matter what, I'll be serving the response in let's say 100 milliseconds. So you can keep your SLA for 200 milliseconds or something. Right? But timeout contract should definitely be there. Now let's see when search service was like, when service 1 was communicating with service 2 and service 2 didn't send a response, what should be, like how should we handle that timeout? Let's say the timeout happened, now how should we handle it? So we'll discuss 5 approaches to do that. Approach 1, ignore. The best one, let's assume that but obviously not recommended, but like when you don't catch any exception, this is what you are typically doing. You are ignoring where you made the call, where your search service made a call to analytics service, and it resulted into, and it basically waited for some time, didn't get a response, it just ignored it and just moved forward. So whatever the partial response that it had, it just sent it to the user rather than waiting ki, hey, what needs to be done. So just ignoring the no-show of that other service, that okay, let me move forward with it. So here one thing is that we either assume that the operations, like in some cases where we may assume that the operation is succeeded, where we did not get a response, like not in search and analytics use case, but some other use case. Let's say you want to asynchronously store something in the database and you put the message. You didn't get a response, you didn't get an acknowledgement from it. Let's say you are putting a message in, let's say a broker, let's say a RabbitMQ, but you didn't get a response saying that, hey, you didn't get a response from RabbitMQ that says that, hey, I have stored the message. So you can assume that message is stored. But in reality, it might have happened that message is not stored in RabbitMQ for other to consume. Right? So it depends. So you can assume that the operation that you are trying to do has succeeded, but in actuality it fails. It leads to unpredictable user experience. Right? You think it's done, but it's not done. So ignore as an approach might not be the best thing to do. But in some cases, it is good to ignore things and just move forward, right? In life and in microservices, both. And so a good practice to ensure is that always catch all the exceptions that you get and handle them in an informed way. Ki, hey, timeout happened, waited for the response, something went bad on the other server or other service, you get a particular exception and whatnot. So handle all of that exception when you're making a synchronous TCP call, a synchronous message broker push, anything. Handle it, handle exceptions and take an informed decision depending on the type of exception that you'll get. So there is a, like anytime you make a call to the other service, you know what kind of exceptions to expect. So do that depending on the context, do it very well. Do not just ignore. Right? But in some cases you can do ignore, by the way. Approach number 2, configure and use defaults. So let's say in case of search and analytics service, this fits in very well. So wait, I'll move here and there. So let's say with respect to configure and use default, let's say you have search service and analytics service. Your search service waited for let's say 200 milliseconds for it to get response. The only data it was relying on analytics service to get response was the total number of blocks. What if when the timeout happened, which means for let's say it waited for 200 milliseconds but it did not get any response. So what you can do? You can use a default value. Let's say total number of blocks is equal to 0. Right? You were waiting for a response but you didn't get it. So you are using total number of blocks equal to 0 as a default value. So this is another way of handling timeouts, where in some cases it might be possible for you to use a default value. Instead of not returning any response to the user, you can just use a default value and then send it to the user. Okay. Approach number 3, the most famous one, retry. So this is where you assume that if you do not get a response, so whenever there is a timeout, you assume that the remote operation failed. So then you retry it. Right. So retries are very simple when it is read request. Like in search and analytics use case, it's very easy for you to retry. So you waited for 200 milliseconds, you didn't get a response. So your natural response to that is, hey, let me retry that. Right. So you will retry you'll basically fire the same thing again on an analytics service, waiting for the response, expecting that now it would return you in let's say 50 milliseconds. Right. So retries are simple, and it is simple for read request. But they become very tricky when your request is non-idempotent. Like what is idempotent? Which means that same operation fired twice will not have any repercussions onto it. So other service is handling it well. So like you fire the same thing twice, nothing like basically nothing weird happens on that. So you can fire the same operation as many times and it would lead to the exact same thing on that particular end. So your request is non-idempotent. For example, a good example for that of non-idempotence is, let's say you are transferring money from account A to account B. If you do retry, let's say you fired a query that does transfer from that transfers money from account A to account B, but you didn't. But when you fired that query and you waited for that response, it resulted in a timeout. Now, if you retry this operation, so let's say A wanted to transfer 10 rupees to account A, the overall money of basically 10 rupees needs to be transferred from account A to account B, and it failed because of timeout, and you retried it, right? So, but it was actually a success. But when you retried it, instead of transferring 10 rupees from A to B, now 10 plus 10, 20 rupees got transferred to B's account. B is happy, but A is not. Right? So this kind of requests are non-idempotent requests. So you need to know that if the communication that you are doing between two services, if that other service ka request is idempotent or not. If it is not idempotent, then you definitely don't want to retry. Right? Second is like when this becomes tricky, when retries become tricky, is when your request is expensive. Let's say there is a very heavy real-time analytics query that you are firing that is computing a lot of things in real time, which is very heavy on analytics. But that is, you are doing it synchronously for some reason, but if it's a very expensive to compute it, you might want to not repeat that operation. One of the use case would be maybe a very heavy deep learning based, GPU based some query or some request that you are firing, not really synchronously or something, but it's very heavy to compute. So you may choose not to do it, right? Then third thing is when the situations become tricky is when other service is overloaded. So the idea is, the situation is, let's say your search service was depending on an analytics service and you fired a request analytics, you didn't get a response, and there was a timeout. So you said, hey, let me retry. So you are continuously retrying to make the call to analytics service, but in reality, analytics service is actually overloaded. So your retries is making the situation worse for analytics service. So that's where you need to know when you should be retrying. Like in this case, when your other service is already overloaded and you are firing that query again and again, again and again, then the load will never decrease on that service. So that service will never get time to recover, right? So retries become tricky then. So a few good practices to take care when you are sure that you would want to retry is retry with exponential backoff. Do not just immediately like apply for loop and just keep on retrying immediately, like it failed, retry, it failed, retry, it failed, retry. This is where you typically see exponential backoffs kicking in, which says that, hey, you first make a retry in 1 second. If you still get a timeout, you retry after 2 seconds. If you still get a timeout, you retry after 4 seconds. So there is an exponential backoff that you are doing. So 1 second ka delay, then 2 second delay, then 4 second delay, then 8 second delay, and so on and so forth. And other thing that you definitely should think about is where, like, if your dependent or if your depending service is idempotent or not. So anytime you design a service, try to make it as idempotent as you can. Like, just ensure that if you are leaving out a scope of idempotence, it should be very minimal. Make it as idempotent as you can, because that would give you that would give other service the confidence to make as many calls as it can without leading to any weird behavior. Approach number 4, retry only if needed. So in the third approach, we chose to do continuous retry, or we talked about retrying, but approach number 4 says you can retry, but only when it is needed, which says that somehow you have this option to check that, hey, if this requires a retry, then only I'll retry, otherwise I'll not. For example, in some service, you might have a way to check if the operation is successful or not. So you fired a query to service A. Service A talks to service B. Service A, when made that operation, didn't get a response. It led to timeout. But somehow, when your service A tried to retry that operation, it had a way to find out if that operation that it did previously was success or not. Somehow it has a way to find it out. We'll go through one example on what exactly happens, like how it can be seen in real world. But if it has a way to find if that is success or not, right, you can leverage that you will choose to do retry only if your past operation was not a success and you have a way to check it. An example is, let's say, a user tweeting the same post twice accidentally within a particular time range. Let's say Twitter added a check saying that, hey, a user if post the same tweet twice within 1 minute, it might be like user when clicking on tweet button might have accidentally clicked it twice. Maybe some bug or something happened. Like, so to prevent this situation, what Twitter might do is, like, let's say the JavaScript client of user is doing that retry. The user made a /post request on Twitter's API server or something. It stores tweets in this database. Right. So when user fired 2 queries back to back, right? So when user fired one API request to tweet something, this tweets get stored in a cache or something where you are storing user one's recent tweets, right? So user U1 made a tweet, user 1 recent tweets are stored in an array in some cache, let's say a Redis or a memcache or something, and then it is storing in the main database where the tweet is actually registered, right? And now somehow user 1 didn't get a response from the Twitter's API. So user made a /tweet request to Twitter, but it didn't get a response. So JS client of user 1 retried it. Now, because that retry was done very quickly, your Twitter might just check in the cache to see, hey, did this user just made the same tweet? If the user did, then your Twitter API might send an error saying, hey, I think you just made a tweet. You might want to, do you really want to repeat that? Right? Something around that. So I've seen this behavior in a few websites out there with mostly social media websites, in which it just gives you a warning that says, hey, are you sure? You just tweeted the same thing a few minutes ago. Do you want to retweet that? Do you want to again tweet that for that sense? So this is one solid use case where you are retrying only when it is needed. Right? Approach number 5, Rearchitect. So like one thing to always think about is, why do you need a synchronous dependency in the first place? Can you make it asynchronous? So for a search and analytics service, you might want to think twice before you do that, where request comes to search service, from search service it goes to analytics service synchronously. What if analytics data is ingested in your Elasticsearch? So it removes your dependency on analytics service altogether. Right? So always think about something like have a microservice silo. If anyone wants to communicate to this, think about, can you make it asynchronous? Can you remove the dependency? Can you remove a synchronous dependency on that other service? If you can, that's the best possible thing that you can do. So few good approaches, this like going for an event-driven architecture, or ingesting the required data from that other service into this service, so that this service, like your search service, works independently without having a synchronous dependency. So try to remove synchronous communication as much as you can. Go for an event-driven architecture. Re-ingest the data, duplicate the data into your service, like ingest it in your service, and multiple ways to do it. But re-architecting your solution might be the best long-term solution that you can go for. In some cases it is not possible, but in most cases it is. So try to think in that way. Right. So from this entire discussion, a few things that we can definitely have as a key takeaway. First, always have timeouts. Whenever you are doing communication, synchronous communication with any service, have timeouts. You cannot wait forever. Right. Second, picking a timeout value is very tricky. Like if it's too short, then you'll have a lot of false positives. Let's say it takes for your database, it takes for analytics service to respond in, let's say, 200 millisecond, and you are having timeout of, let's say, 150 millisecond. So unreal expectations from it. So in most cases, you would have a response, but you would still be seeing timeouts. So a lot of false positives if your timeout value is too short. But if it is too long, you'll have a performance bottleneck, because you are waiting for far long. Let's say if you're waiting for an analytics service to respond in 2 seconds, so you're waiting for far long. It is putting a lot of pressure on your service as well, because the throughput of your service is going down, and unnecessarily leading to a poor user experience. And third thing is, make retries safe wherever possible. Try to design your service with idempotence in mind. If you are not thinking that, then retries will become very tricky for the services that are consuming your service. So try to be as idempotent as you can with respect to your implementation. Right. Nice. So that's it. So yeah, basically that's all what I wanted to cover with respect to handling timeouts in a microservices based setup. So I hope you found it interesting. So if you folks like this video, give this video a big thumbs up. If you guys like the channel, give this channel a sub, and I'll see you in the next one. Thanks, Satan.